Let's look at 3.4a, Fundamental Theorem of Algebra, starting with real roots. So the fundamental theorem of algebra is that if you have a polynomial of degree n, where n is greater than 0, then f has at least one 0 in the complex number system. So that means we have real or imaginary parts. Or we could have both. So we have at least one 0 in the complex number system. Okay, the linear factorization theorem. Go ahead and look at that. We have an, f of x equals an, parentheses x minus c, parentheses x minus c2, and so on. Then it has precisely n linear factors. So we're going to look at that. Then we see that c1, c2, cn are all complex numbers. So we are going to find the zeros of the function. So let's go ahead and start with this one. So the first thing that we want to do is we want to go ahead and graph it on the calculator. So let me go to my calculator. I'm going to go to y equals. I'm going to put that function in. X raised to the third power minus 4x squared plus x minus 4. I'm going to graph it. I'm going to look at what it looks like. And I'm going to see where does it cross the x-axis. So we have at least one real 0 and it's 4. So I'm going to kind of draw a picture of what it looks like. We have 4 here. And we have, this was at negative 4. But it went like this. Something like that. And remember, it's cubed, so it does go in different directions, and it's positive, so it ends going upward. So what we're going to do, since we know that we have a 0 at 4, we're going to do synthetic division, so then we can make it a little bit easier to find all the other zeros. So we only have one real 0, so one real 0. And we are going to have 3 total zeros, so that means we're going to have 2 imaginary. And the reason is because this is 3, so 3 zeros. And so this is a breakdown. One real, that's the one that we saw, and so that means we have to have 2 imaginary. So let's go ahead and put our numbers down for our synthetic division. And let's do it. For remainder, 0 remainder, which is good. That's what we wanted. So what's left is x squared plus 1 equals 0. That is what this is. So then we solve. So minus 1, and we get x squared equals negative 1. And we take the square root. So then we have x equals plus minus I. So then our zeros are x equals 4, x equals I, and x equals negative I. So what we can do is we can write out our function like this right here. Okay, so then our function's going to be, I'm going to change my color real quick. F of x equals x minus 4, x minus I, and x plus I. So we have one real root, this is our real, one real, and then 2 imaginary or complex. Okay, let's go to the next one. Okay, so we're going to start with graphing this. I'm going to go back to my calculator. So go to y equals. We're going to clear that out and put it in. X raised to the fourth plus 4x squared plus 4. Hit graph. Okay, so right away I see there are no x-intercepts. So that means we have no real roots. Roots, zeros are all the same thing. All the different names. So it kind of looks like this, right? And this is at 4. So we are going to have 4 imaginary roots. So I need to see if we can break this down. So this is x to the fourth, 4x squared plus 4. So what we can actually do is we can factor this like it was x squared. So we're going to factor it like x squared. So plus 2, and then x squared plus 2. And then we're going to solve it. So x squared equals -2, take the square root. So x equals plus minus, that would be I squared to 2. Okay, so that actually can be written like this. X plus I squared to 2 squared, because it's a double root. X minus I squared to 2 squared. This is our f of x. So we have 4 imaginary and no x-intercepts. So this is a double root. Okay, so let's look at the next problem. We are going to find all the zeros of the function, write the polynomial as a product of linear factors, and then use that factorization to determine x-intercepts on the graph. Use a calculator to verify that the real zeros are the only x-intercepts. So let's look at this first one. So I would first see if I can factor it. So I would look at, okay, can I do, let's multiply to get 46 and add to get -14. 2 and 23, and that's not going to give me -14. So when I see that, I go ahead and do quadratic formula. X equals -b plus or minus square root of minus 4ac all over 2a. Okay, so we can put what's in the radical in the calculator. That'd be 12 over 2. This is square root of 4, square root of 3. So I can rewrite this as 14 plus or minus 2 square roots of 3 over 2. Then I can simplify it even more. I can divide everything by 2, and that gives me 7 plus or minus square root of 3. And this is a quadratic, it's squared, so that means we have 2 zeros. So our 2 zeros are x equals 7 plus square root of 3 and x equals 7 minus square root of 3. So we are going to, we found the zeros, that was A. B, write the polynomial as a product. So it's going to be f of x or y equals x plus, no, I want to do minus. X minus because we're going to say in order to get that, it has to be minus 7 plus square root of 3. And then x, to get this one, it's going to be plus 7 minus square root of 3. And this is in the factored form. Okay, so we can look at the graph now. And these are real because there's no imaginary part. So we do have two real zeros or roots. So we're going to look at the calculator now. So go to y equals, and we are going to clear what's already in there, and let's put this one in there. Oh. X squared minus 14x plus 46. And hit graph. 5.227 and then 8.73. You can't click on those on your regular calculator, so what you're going to have to do is look at the table and figure out where exactly would it be. So let's see. I want to get to where the x is close to 0. So where does that fall? It falls between 5 and 6. And we can also change the table set. Hit second window, and we want to do it by halves. Okay, so now we can see that it's actually between 5 and 5.5 when we look at the table. And then the other one is between 8.5 and 9. So that's how we can kind of narrow it down and make sure that we did it correctly. So now go to our home screen, and we're going to put in 7 plus square root of 3. That's 8.73. And then do 7 minus square root. 7 minus square root of 3. I think I just did times. Let me back it up. Okay, so those are our two zeros. So I'm going to write that over here. So this is approximately, what was it? 8.73. And this one is approximately 5.27. So those are our, right? Yeah. And those are our real root. Use calculator to verify the real roots are only the x-intercepts, which we did. We looked at the table. We looked at the graph to verify that. Let's go to example 4. Okay, so I want to, since this is a cubed, I know it's going to be like this somehow within our graph. And we're going to have at least 3 roots. Some of them may be real, some may be imaginary. So let's go ahead and put this into y equals. Clear what's in there. 2x cubed minus 3x squared plus 8x minus 12. Graph. Okay, so it looks like we have one real root, and it's at 1.5. Okay, so we are going to use 1.5, which it's actually going to be like 3 over 2 is 1.5. And let's do synthetic division. That'd be 3, 0, 0, 8, 1/2 of 8 is 12, so that's 0. So it's our remainder. So we have 2x squared plus 8 remaining. So we can factor and solve this. So let's go ahead and do that. So we have 2x squared equals negative 8 divided by 2. X squared equals negative 4 square root. So x equals plus minus 2i. So our roots are 3 over 2, 2i, and negative 2i. Those are our zeros or roots or x-intercepts. So we write this as the equation f of x equals, in order to get 3 over 2, this could be how it could be written, x minus 3 over 2, x minus 2i, and x plus 2i. So in order for x to be 3 over 2, it has to be x minus 3 over 2. So don't forget that, because we're actually solving it and saying it equals 0 and then solving for the x. So we have one real and then 2 imaginary. Okay, let's go to the next one. We have a cubed again, so it's going to look like this. And we need to find out what one of the x-intercepts is. So let's put it into y equals x cubed minus 7x squared minus x plus 87. Now hit the graph. So we can look here. We can also look at the table. Remember, we're looking where y is 0. Oh, there it is, negative 3. So negative 3 is one of our zeros. So it's going to look like this. Negative 3. How did it look? Let's look back at our graph. So somehow does this. Let me zoom out. Zoom out. There we go. So that's a general, like that. All right, so we're going to do synthetic division for negative 3. Okay. Negative 3 times 29, negative 87. We get 0 as our remainder. So we are left with x squared minus 10x plus 29. Okay, I look at that one, I'm like, there's no way I can factor that. So it's 29, and we know that it's going to be imaginary anyway. It's not going to give us an actual number, so it can't be factored into binomials. So instead, we're going to use our quadratic formula. Okay. It looks like whenever you multiply, so that's 100, and then 4 times 29. 4 times 29, 116. So it's minus 116. So that gives us square root of negative 16 over 2, which is 10 plus or minus 4i over 2. We can simplify it even more. Divide by 2 all the way through. 5 plus or minus 2i. So then our zeros are negative 3, 5 plus 2i, and 5 minus 2i. So then our function is f of x equals x plus 3, because in order to get the negative 3, it has to be the opposite. X minus 5 plus 2i, and x plus 5 minus 2i. Okay. All right, this next one we have to the 5th power, so we know it's like this again. So we've got to find some roots here. So I'm going to go ahead and put this into the calculator to see where we're at. So x raised to the 5th plus x raised to the 3rd plus 2x squared minus 12x plus 8. Okay, hit graph. I'm going to zoom. I'm going to go to standard. All right, so looks like we have -2, and then there's a double root at 1. So I'm going to start with -2. It's going to be like this, -2 and 1. So it's like this, something like that. All right, so we're going to start with the -2. So 1, oh, there's a 0x to the 4th. 0, 1, 2, -12, and 8. Let's go ahead and do our synthetic division. Oh, so that worked out. So then we know 1 also, right? So I'm going to use what I just had. I'm not going to put it into like the x to the 4th negative. I'm going to go straight in to my synthetic division. I'm going to do it with this line because I can keep on factoring and dividing. So let's go ahead and do that. Oh, it's not -1. Sorry, that's a +1. So fix that real quick. Okay, so now we have a -1 here. All right, so remember we have the double root. So we can do that again. We can divide it by 1 again. Okay, so that leaves us with x squared plus 0x plus 4. So x squared plus 4 equals 0. Then we solve that. So I'm going to come over here. X squared equals -4, square root, x equals 2i, plus minus 2i. So then my zeros are x equals 1, x equals -2, and another 1, because it's a double, right? This is my double. And we knew that because of it touched and turned. And then we have 2i and -2i. So then we have to write our equation. So f of x equals x minus 1 squared, because it's a double, x plus 2, x minus 2i, and x plus 2i. Okay, that is it for our notes today.